Let's continue by working out the skin of this building. And this is a bit tricky because there are several ways you can model a facade system in Revit. You can use the model wall by face that I showed you floors by face in the last exercise. The wall by face is a similar command. You can just click it and then you select any kind of wall, generic or curtain wall, and then just stitch it to any surface on the mass. But if you're going to have a curtain system or like a glass system or with any kind of crazy pattern thing, you're going to have to use a different method. Basically, you can create pretty cool patterns inside the conceptual massing environment, which is basically where you make this mass. But there's a problem with divided surfaces and like adaptive components and these like kind of crazy components that you can use to create a cool pattern on your facade, and that they're not room bounding, which basically you need some kind of room bounding element inside your model to keep the rooms for or to have the correct areas and outer boundaries for rooms. We'll get into details on that later. Basically, what I'm talking about is that if you open level 23 and you start making rooms, they won't be enclosed. So you need closed spaces in order to start placing rooms. Now, as I said, there are different ways you can do this. One way that I think that I'm like is I just create a curtain system that's empty on this building, and then I start playing around with the facade inside the conceptual massing environment. So this will be a dual exercise. First, we'll create a pretty simple empty facade just for creating room bounding elements, and then we'll create the real facade inside the conceptual massing environment afterwards. So first of all, we go massing inside, we go model by face, and we go curtain system instead of walls. We go curtain system, and the curtain system that is by default selected for us is the curtain system 1500 by 3000 millimeters. So before we click anything inside our model, so you can see now that Revit is asking us to stitch this curtain system to any of the faces inside our mass. So let's change this guy first. So we go edit type. I'm going to rename the type to just curtain system or none or whatever. And then I'll select the curtain panel is going to be an empty system panel. And then I say grids, no. Grid 2, no. No grids. Okay. And then I'll orient my model. Now you can use the view cube here. I click left. And then I draw a crossing section or a crossing window on all sides across the entire building, but I don't include the bottom, the floor, the ground floor of this model. This is basically because I don't want a curtain system on the floor inside my building. So when I let this guy go now, and I say create system, I'm actually done in 2 seconds. So I click modify or escape, and then you'll see that you can click on something that's here. It's called a curtain system, and it's actually a facade thing. So you can go into this guy and change around, adding grids, adding the distances between grids, adding panels and everything. But as I said, it's not going to give you a lot of options for making a pretty cool facade. So in case you want to make a cool facade, you have to do different things. But this guy here, he's room bounding. And that's pretty sweet because now you can go back to level 23 and you can start adding rooms like this. It's an enclosed room. So when you add this room, it's going to give you an enclosed room with like areas and all kinds of information that you can use later on when you start designing your floor plan. So we'll touch on that later. Now, next up, I'm going to give you a pretty quick introduction into how you can make something of a facade that looks a bit more interesting than just a normal uniform facade. So to do that, you need to enter the conceptual massing environment. Now, for a placed mass like this, you just open the family. Like I said earlier, in option number 2, we have this guy here. You just go edit in place, which is something else. You enter sketch mode for this family inside the same project environment. And now, the placed mass that I modeled in option 3, if I open edit family, it will actually open a separate file This is I haven't touched really much on that yet, but this is a separate file. It's called form RFI. That's the file shortcut for Revit family. So basically inside here, you don't have access to the project information or whatever. This is a different separate family, and you can use that in any other project or whatever. My colleague can sit and edit this family in a separate Revit session, and then I can just load it into my project. So the interesting thing when it comes to facades in the conceptual massing environment in which I am now is that you can click on any surface, really, and then use a divide surface tool. So basically click on any like one or several surfaces, faces, and then you click divide surface. Divide surface will now put an element on your surface, and it's going to have a grid. So this grid, you can change the grid spacing using these new parameters that you get access to. You have a UV grid that you can change parametrically. So if I change the U grid number to 20, you see that it gets a much denser grid vertically. So let's change this guy back to 10, or this guy V grid to 20. You can see that it has it gets a much denser grid vertically or horizontally or whatever. You see what I mean. The other thing that you can do that is pretty cool is that you can change the pattern. If you click on this grid, if you've selected it, you can go to the properties palette and change the pattern to something else. Arrows, or hexagons, or octagons. And you can still change the grid spacing, 30 like this, or 15 like this. And this is pretty cool. And this is much more flexible, parametric, and I think beautiful than anything you can do with curtain systems inside Revit. So let's change this guy to something like a rectangle checkerboard. And then we can start parameterizing this guy, because we want to parameterize. We want to have parameters to change the spacing of these grids. So one way you can do that is to change the actual layout of your grids. Basically, instead of a fixed number, you can go maximum spacing or fixed distance. So when I change the layout from fixed number to maximum spacing, I use different inputs. So this is now, instead of when I go back to fixed number, you say 16 or 15 or 14, and it will just change your spacing. If I go maximum spacing, I have to enter a real number. So basically now you can change this guy to 1 meter, for instance. You get an insanely dense vertical spacing between the checkerboard panels. And let's change that guy back to 2 meters. And you can also associate that parameter, which is now just the U parameter, U grid parameter for this divided surface. Let's associate that parameter with a new parameter by clicking this small button right next to the distance that says 2 meters right now. So I associate this parameter with something else. Let's call it grid. I already have a parameter. I've cheated, so sorry about that. So I'm going to associate the maximum spacing distance parameter with a new parameter called grid. So OK, and then it changes to what? 2310. Cool. So let's do the same thing with the V grid layout. So I go maximum spacing, I associate the distance with the same parameter, grid. Perfect. Now you notice that the grid spacing is identical in both directions. They're identical in the U direction and identical in the V direction. It has 2.31 meters spacing. Now the power of this is that I can, by using the family types dialog box, I can go and change the grid spacing of multiple directions. So I change it back to 4 meters or 2310 like this. And I can also click on this facade and this facade and the back facade, for instance, like so. And then I go divided surface. I go from no pattern to checkerboard pattern. I can change the maximum spacing and associate the parameter with the grid parameter, and do the same thing in the V direction. And now you see the real power of this parametric way of working with elements inside Revit. Now I have one parameter, it's called grid, and when I change Mr. Grid here, not 45 meters, just 4 meters, and apply, it changes the grid spacing of the entire facade. So that's pretty cool. And I'm not even going to go further with this. Let's just say that the rectangular checkerboard here is a set, and the rectangle, the octagon rotate. All these patterns are predefined patterns, and you can make your own based on all these templates. But basically, there's a lot of possibilities here, and you can start playing around with adaptive components that not really suited for Revit basic training, but there's many possibilities to do cool facades inside Revit. So now we can either load this guy into our project, or we can cheat and load a family that I already made. And I think you can guess which option I'm going to go for. So I'm going to go Insert, Load Family. Insert is a tab inside Revit, basically where you pull in anything that's not in a Revit family natively, and you pull stuff like other Revit files, IFC files, CAD files, point cloud files, whatever. And you can also load another family just using the Load Family tool here. Let's go back to the references, and then I have a family called Facade. So I'm going to load this family into my Revit project. I'm going to click on the Form family, and I'm going to change it to the Facade family, which is basically the same family, but just with the parameterized grid. And that's it. Now I have a pretty cool facade with a checkerboard pattern around the main body of the building. I have some solar panels up here, I have some glass panels back here, and I have some glass panels back here. They're really glass panels, although they're not transparent right now, but basically a pretty cool pattern. And I also have the room bounding curtain system that allows me to add rooms, which is basically best of two worlds. So next chapter, we're going to start looking at wall elements inside Revit, and we'll start working out a plan. See you then.